Hello and welcome back to the video series where we go over the Project Resource Manual published by the Construction Specifications Institute or CSI. And today we're going to talk about Module 4, which is design. So in the previous modules, we discussed that we already figured out the project delivery method. We know the budget, the owner delivered the programming documents, such as survey and geotech information and other required things. And then we figure out the project team, we selected all the team members. So now we're gonna start with the design. And there are two main phases. One is schematic design and then design development before we jump into the construction documents. And that is actually module 5. So with the design progress and phases, there are phases and there are defined by the American Institute of Architects or the AIA. You can go to the AIA website, which is aia.org, and see all the information there. It's free of charge. You can see the samples of the documents and you can see what documents are actually necessary for each design phase. So in the schematic design, what actually happens there? The site plan and the area relationships must be defined in general, just size, shape, massing, what building elements are required, and some simple elevations and exterior finishes are established. And then the plans, like very simplistic plans, need to be developed during the schematic design. And that will go to the owner for approval. The owner needs to approve that before we can continue with the design development. And with when we go to the design development phase, then all the building systems in general, such as structural, mechanical, electrical, plumbing, and other like security or acoustical systems, they are usually developed by selecting the air handling unit size, or just in general trying to understand what the project may require. And then the outline specifications are developed during the design development. Let's go actually into details. Sometimes there are variations. If it's a prototype design, then this phase may be really shorter, just because there are more prototypic elements and details, and you can use them and just like they kind of like transfer from one project to another. All you need to do is just adjust to the site and the code requirements and whatever jurisdictions requirements are. Then if that's a master plan and this particular building is going to be one of the many, then the site planning needs to be more elaborate, and that will be traveling from one project to another, from one building to another with the same site plan. Then when you consider the requirements, what actually we need to look at, there are some regulatory requirements, such as authority having jurisdictions. They have some zoning requirements with the setbacks or other restrictions. Then they have the building height, floor to area ratio, and that will be actually, that can be inquired from the local building department. All you need to do is just go to the website and get that information, or give them a call. Sometimes it's easier to call them or email them. Then the site use and environmental requirements. So that can be another issue, and you can deal with the EPA or Environmental Protection Agency or other jurisdictions, and that needs to be done in advance, like for the erosion and sedimentation, or the stormwater on site, or how you use the wastewater, and other things. Building codes, yes, always check the building codes before you do anything, just because they are updated, and sometimes they update them on the website, sometimes they don't, but they no longer accept the projects under the previous version of the building code. So always check. It's always a good practice just to pick up the phone and give them a call and ask the jurisdiction what the up-to-date requirements are. And we always need to remember that the architect's primary responsibility is to take care of the health, safety, and welfare of the general public, and so is the contractors. So we always need to have that in mind and just deliver construction safety and deliver everything just according to the agreement, according to the specifications and the construction documents. So when we talk about the functional requirements. So that was determined in the programming phase, and here it's more refined. So it gets more refined. We understand the levels of that. We need to maybe propose something to the owner. If that's a design build entity, then the contractor can step up and say, hey, like, I think this is going to be better to use this particular material, and that will affect the whole design. Then sustainability requirements. Now it's getting more and more embedded into the building codes. For example, in the state of Washington or in the state of California, that is already there. The green building principles are already there. So there are requirements, and all the teams need to follow them, especially for the new construction. Then when we talk about sustainable design principles, that can be done before any design starts, like the building orientation, and you need to evaluate the site and understand where actually it's best to build in order not to disturb the flora and fauna there, and so on. There are a lot of green building certification tools, and the most popular one is LEED. This is not the video about the green building certification, but this is something to consider. So when the owner selects, for example, to get LEED Gold for the building, then in the very first schematic design phase, you need to make sure that that is addressed. So that is always kind of like a back and forth with the sustainable consultant or whoever is hired for this compliance. So that is something to consider. Then when we talk about the aesthetic requirements, so that is something we can like there is a saying that there is no actually the architectural project is never finished, and there's always room for perfection. So sometimes people need to stop that project perfection syndrome and kind of like put the pens down and just uh, stop beautifying the project. But this is where we actually begin to do that in the schematic design. So you start to consider like how the building is going to look, not just what the functionality is, but the aesthetic requirements and beauty in how the building is going to be perceived in the urban environment. Then if the contractor is involved early in the project, such as design build, for example, then they may give their opinion on the constructability of the project. So sometimes there are crazy ideas of the architects that need to be brought down by the structural engineer. If they say like, hey, like this is beautiful, but it's impossible to just construct that. Or the contractor, they will say, I don't know how to do that. Like this is something innovative, that like some cool design or cool materials that the owner wants to use, but we really don't think this is something we can build. So that needs to be considered too. And it's always good to have like a second pair of eyes, just to look at the project, to look at the drawings and understand. Also here in the schematic design phase, the budget needs to be reevaluated, reconsidered, and then when the design team gives the project estimate, that needs to be aligned with the budget. And we'll talk more about the project estimate, and that will need to be brought back to the discussion after every phase. So when we talk about the product evaluation and selection, so there are some products that the owners would like to use, and they have like some required performance, and they have some other wishes that they would like to implement in their project. This is their project, so they would like to do something that is meaningful for them. But usually it's good to look not just at the project or the availability of the project, which is sometimes an issue too, with the volatility of the markets, but also the life cycle assessment, the life cycle value, just to understand how much the whole thing is going to cost to the owner when the building is up and running and when everything is already built. So that is something good to consider as well, and that's something to talk to the owner about. If there are like custom materials or products, like that is something the design team always needs to discuss with the owner. Also, some of the products may have a really long lead time. So if it's like super custom made material or product, that may take a few months to be developed or to be produced. So that needs to be actually embedded in the project schedule. And this is what is important here. So the project schedule can be tweaked here just to understand and to add those products there. So when we talk about the specific product information that needs to be obtained from the like local suppliers or manufacturers or sales reps or any type of connections that the architects may have or the owner may have. Sometimes the owners have their own manufacturers, their own suppliers, and they would like to use them. So that's something to consider as well. If we talk about sustainability in the materials, the preferred materials are locally sourced within like 100 miles around the project. So that is something to consider too. And like instead of like bringing like super expensive marble from Italy, sometimes you can look around and see if there are quarries in your area where the project is located. Then also the manufacturers and the factories can help with the drawings. They can provide shop drawings. They can provide the product specifications and product information that can be already incorporated into the design. Sometimes they even have Revit files with the like all the products in Revit, so you can just copy that and paste into your project, and you'll be good to go with all the correct dimensions, so you don't have to reinvent the wheel. And also the manufacturers or producers can help with writing the specs. They may not be always fair, and sometimes they will just help with the specs, but then they will just prescribe the product that only they produce. So you need to be always kind of like on the lookout for that. Also, when estimating the cost, the suppliers can help too. They can just evaluate what they can do, what they cannot, like how much the market is going to change in like 12 months. So they can provide that information, as well as the constructability. So they'll say, no, our product is not designed to be used in the load-bearing wall, so or like it's not going to be structurally safe. So they can definitely help. So don't be shy to talk to the manufacturers. And if you are a construction manager or a contractor that works with the architect, you can always advise and always start that conversation. So if we talk about prefabricated products such as wall panels or any type of products that are assembled on the site, but they're produced somewhere at the factory and then delivered already, and then they just kind of like Lego blocks put together on the site, that actually can help minimize the construction time, and that can help minimize the design development phase as well. Just because it's already there, those panels have standard sizes, and you can use them, and you can always get all the information and all the plans that are necessary. So there are a lot of reference standards, and you need to be aware of them, such as and that will be needed for the quality assurance and quality control. So when you consider evaluating the products, you always need to have like at least a couple of them to compare, because sometimes there's like a short supply, or something may not be available, or something just is not really suitable for a project. So you always need to be aware of the alternates, and then that will be very helpful for any phase of the project. Then when we talk about the installation of those prefabricated items, that's something that needs to be communicated as well and coordinated as well. Like, who is going to do that? Is it going to be the representatives from the manufacturer who are going to come and do that because they have specially trained people, or it's going to be a contractor, or it's going to be some other team, the owner's team? So that needs to be discussed as well. Then when we talk about the decisions, of course, it's easier to tweak the decisions in the beginning of the project. And that's why and it's the cheapest, the most effective and cheapest way to incorporate any changes is the beginning of the project, instead of when like everything is already built and then the owner is like, hey, actually I want to do it, the other way around. So, and then you have to just demo the whole thing and then build it again. So that will require additional cost, time, and scope. So if we talk about quality of the project, the quality actually needs to be established in the contract documents. And the architects are actually held to the standard of care. And that means that the architects should never sign a contract where the owner requires like the top quality or the highest standard, or like the best in the area. Like, they should never sign that just because they cannot deliver that. Contractors should never subscribe for that either. So that's something to consider, and that's something that is very important, and the owner will hold the design team and the construction team accountable. Also, when we control the variables, there are a few methods to do that. One is allowance, then alternates, and the unit prices. So allowance is something like a specified monetary sum, specified quantity or time that cannot be otherwise defined by the specs or drawings, but we will need them. So for example, we'll need something for the for some type of equipment that will be determined at a later time. Then the alternates, that is a defined portion of the work that is priced separately. And actually that provides an option for the owner to determine the final scope of the project. Then you can do the unit price as well. So that is just something simple that you don't know how many of those units you're gonna have, but you need to incorporate that. For example, like excavated soil. So you don't know how many cubic feet you'll have at the end of the project. So when we talk about the cost estimating, that needs to be done after every design phase. You need to go back and say, okay, so with these conditions, with these market conditions, with the like labor cost, and with the like owners requirements, because owners may change their mind every so often, and that will actually inform the design decision, that will inform the budget. So that needs to be re-evaluated. And value engineering is something everybody is afraid of, like the change orders later in the construction, but there is nothing to be afraid of. This is something that happens every time in the projects, whether it's like 100 of change orders or just one. So, but there'll always be changes, and that's totally normal for the construction project. So when we talk about the estimates, we should always consider the life cycle cost. I already mentioned that, and that's something that you talk to the owner about. So, for example, if they would like to install like a super high-tech light and fixtures or something, they need to know how much they're going to pay for the electricity down the road, not just for the beautiful design. So that's something to consider as well. Okay, so when we start the schematic design, what actually happens? The architects team get together, they involve the engineers, if they have them in house, or they they sign a contract with the engineering firms, and they start working on the drawings. They create the system descriptions, then the performance criteria, then the use of system, that like how that is going to be coordinated. So that the first round of drawings actually is like rough estimate, is just kind of like making sure that all the systems interact well, and the HVAC ducts do not run through the structural columns or something like that. So that will be fully developed in the construction document phase, but this is something to consider already. And when the schematic design is progressing, what can happen after that, what should happen after that is that needs to be submitted to the owner for the approval. So the owner says, okay, blesses the contract, the schematic design documentation, and then the architect's team proceeds to the design development. And in the design development phase, usually the outline specs are developed. So that is just kind of like they contain more detailed design decisions than system descriptions, I would say. So, and that will be fully developed in the construction document phase. Sometimes they have the spec writers in house, but sometimes architects invite a third-party spec writer and they help them, or the manufacturer help them. So that total design depends on the project. Then when the design development progresses, what actually happens is the architects make sure that the main building systems are delivered, like everything is intact, everything works together, there are no discrepancies, and like the floor height is established, and it's enough for all the building systems to be integrated there, like as far as the electrical and HVAC and other systems. Also, the ADA, or Americans with Disabilities Act, requirements need to be incorporated here and considered. Also, the architectural or engineering team, they need to deliver the drawings, and they need to be prepared and coordinated with the outline specs. So that is actually the requirement, to have both drawings and specs, and that is something that is considered to be the conform documents or the construction documents. So also the estimation needs to happen after the design development phase, and like we mentioned before, that is something that people should always bring to the table whenever they have a discussion, like a team meeting or something. So that is critically important to discuss. The product representation, again, manufacturers can help a lot, prefabricators can help a lot, so always have an educated discussion with those. So there are also independent sales reps. They can help you, advise you, or just sometimes they can provide free Revit files, and that will help a lot for sure. So when you work with a project team, that needs to be regular. At least weekly meetings are required to go through the design, to go through all the materials that are available. And that is the constant communication. That is something that people need to be aware of, and people need to plan and schedule. So this is critically important for any type of project, regardless of the project delivery method or contractors team or architects team. So then if the contractor is involved early in the game, and if it's like a design, build, deliver method, then a lot of things can start happening during this. So for example, during the early phases of design, architects can deliver that in packages. So they will, for example, fully develop the foundation construction document package, and that will go to the construction already, while the architects still work on some like interior elements or some other visual or aesthetical requirements. Then when you work with the decision makers, the stakeholders, you should always coordinate that with them. Always be aware who makes decision in the owner's team, whether it's the owner himself or herself, or the owner's rep, or sometimes it's the government, or sometimes it's some other agency that actually has a lot, has power to decide. Then when we talk about the documentation, so what else need to be developed? Well, there is a lot of description about the specifications, like there are different types of them. Then methods of communication need to be established, whether you have a cloud model or you communicate via Teams or Zoom or any type of product. So something needs to be established, and that needs to work for everyone, because sometimes it's not really working for the team, and then that's a problem. But now with the BIM, that is easy, that is affordable, and that is something that you may consider to use. Then after that, what actually happens is you need to collect that information and have it archived. Just keep the folder, keep like a Dropbox or Google Drive or whatever project archiving system you use. Just keep all the sketches, all the design documents there, just in case if you need to go back and check, you can always do that. Then if there are any revisions, if there are any type of changes that the owner would like to do, so it's usually good to communicate and ask, like, are we still on the same page? Do you like what you see? So like always communicate. And also when we talk about the design phases, that is something like after every design phase, it's recommended to check the code, just because if there are any changes, you can always incorporate that in the drawings. And that is basically it. Thank you so much for watching. We're going to continue with Model 5, which is construction documents, next time. Thank you for watching.